show you one way to attack a multiple step word problem. First thing you do is you read the story problem. Macy the clown was holding 4 bundles of balloons to take to the birthday party. Each bundle had 8 balloons. Macy accidentally let 5 balloons pop when she was putting them in her car. How many balloons does Macy have now? Okay, then you start with the question. How many balloons does Macy have now? You're going to rephrase that into a statement and write it down. Macy has blank balloons now. This is where you're going to be sure to put your answer when you're finished. Okay, so you read it one time. As you read it the second time, you're going to take apart the information that you have. You're going to have a step box, draw a step box, and inside this box is where you're going to tell the steps that it would take to solve the problem. I like to ask the kids first, how many steps do you think it's going to be? Some might say that there's 2 steps, some might say that there's 3 steps. So we kind of predict first. And then you start with you go back to the problem. Macy the clown was holding 4 bundles of balloons to take to the birthday party. Each bundle had 8 balloons. Okay, well, what thinking pattern would go with that information? Students would say, equal groups put together. They might think of this as multiplication. We like to give it the thinking pattern, so we label it EGPT. Okay, so you'd start off with 4 bundles, and they each have 8 balloons, which is a total of 32 balloons. Really important that the kids can give the words to go with that number, so it's not just 32. Identifying what that 32 means. 32 balloons total. But then Macy accidentally let 5 balloons pop when she was putting them in the car. So what thinking pattern goes with this? Well, some went away, which is subtraction, so they will put SWA. So you have the 32 balloons minus the 5 that popped, which gives you 20. Which gives you, my mind is,
Sorry, my mind's broken too.
27 balloons. Then we think, okay, is there another step? Or is this what happened after the 5 balloons popped? This is all there is, so there was only 2 steps. So 27 balloons. Macy has 27 balloons now. Okay, so here's another story problem. First thing you do is read the story problem out loud. Mr. Johnson ordered some ribbons to award at the school celebration. He gave out 514 ribbons, and now he has 268 left. How many ribbons did he order to start with? My kids automatically know you look at that question and you put it into a statement. So how many ribbons did he order to start with? He ordered blank ribbons to start with. Kids might not like to do this, but if you begin right from the beginning of the year, they know that this is a must. They have to do it, and they do. They actually add more words because they're so used to writing words. Okay, so we read it one time. Then the next thing my kiddos do is they make a step box, and they look at it and they think, okay, let me read. I'm going to see that I think this only has 1 step, so I'll put 1 right there. Mr. Johnson ordered some ribbons to award at the school celebration. He gave out 514 ribbons, and now he has 268 left. How many ribbons did he order to start with? Okay, my kiddos have also learned how to use a visual representation when they're solving story problems, particularly with addition and subtraction. So this one gives us some information. We know that we have 514 ribbons, and he gave out 514, and he has 268 left. It makes me think of a think board. And this is a part whole think board. So the kids kind of figure out, knowing that this is the whole, up here's the total, these two parts, 500, he gave out 514, and I make a little note, gave out, and he has 268 left. That means we're trying to find out how many ribbons did he order to start with. We're trying to find out that total. Our missing number is the total we're trying to find out. So that automatically the kids know they're going to take that 514 and the 268 and add them together to get their total. So 782 ribbons to start with. Writing this statement also really helps the kids with checking to see if their answer is reasonable. So they go back and they think, okay, does it make sense for there to be 782 ribbons that he started with, and then he gave 514 away and 268 left? That makes sense. So it's reasonable. So the only step that they had to do was sum and sum more. Okay, so starting off with the problem, some classes at Washington Elementary School collected cans for recycling. First grade classes collected 759 cans. Second grade classes collected 795 cans. Third grade classes collected 842 cans. Fourth grade classes collected 812 cans. How many more cans would first grade need to collect to equal the number of cans collected by fourth grade? Okay, so starting off with first grade would need blank more cans to equal fourth. And it's real important that they're writing this because it makes them stop and they have to really understand what that question's asking for. So that's a big part too. Okay, then I make my step box and we think, man, there's going to be quite a few steps in this. I'm not quite sure what those steps are yet, but I know that there's going to be more than one step to come up with our answer. This one has tons of information. So my kiddos kind of can see that, okay, I don't have to write everything down. I could just make it a note over to the side. First grade, 759 cans. Second grade, 795 cans. Third grade, 842 cans. And fourth grade has 812 cans. Okay, how many more cans? Well, I can hear automatically with how many more that I'm going to use a different think board than a part whole. I'm going to make a bigger, smaller difference think board. So I can see that if I make this kind of think board right here, we're trying to see how many more cans first grade needed to collect to equal the cans for fourth grade. So fourth grade was 812, so this is fourth grade. And first grade has 759 cans. So I can see that what I'm trying to find out is this missing information. How many more than? So this is a bigger, smaller difference kind of problem. That's called a comparison problem. So they're going to take that 812 and subtract the 759 and find their difference. So once you think you have that answer, first grade would need 53 more cans. A lot of times my students, we talk about how can we make sure that this answer is reasonable. How can we check to see if our understanding? Well, you could plug it in right here. You can 759 plus the 53 to see if it's 812. So I thought this was a lots of steps. It was just very wordy.